All right, hello and welcome to this session, Cloud Native and Containers on Alibaba Cloud. I'm Jeremy Pedersen. I'm a training instructor from Alibaba Cloud, and I'll be one of today's speakers. So let's go ahead and jump right in. So I want to introduce the concept of the cloud. Don't worry, it's very fast, just one slide. Then we'll take a look at what Cloud Native is, and then we'll have a quick wrap up. And the Cloud Native section is going to focus mostly on serverless Kubernetes and container registry, which is an important part of Alibaba Cloud's container services. So let's jump in. So the first thing I want to talk about is what the cloud is. If you're completely new to cloud, this slide is for you. Essentially, what the cloud does is it converts hardware that you would normally need to buy and put in your own data center or your own co-location facility, and it turns it into a utility, a resource that you buy on demand, like water or electricity. It's as simple as that. It takes something that would normally be an upfront, discrete cost, and it turns it into a continuous pay-as-you-go expense, much like, again, water or gasoline or electricity. So what is Cloud Native exactly? Cloud Native refers to a set of tools and techniques that are used to build applications on the cloud, usually on the public cloud. The reason that there's a separate set of techniques for that compared to what you do in your own data center or with your own hardware is that many things on the cloud can be automated in a more efficient and a more approachable way than they could be in your own data center. So when I talk about Cloud Native, we're not talking about a particular tool or even a particular process, but we are talking about a certain mindset, the mindset of taking best possible advantage of some of the unique features of the public cloud. So it's really about how you build and deploy the application. It's not really about what the application is. It doesn't matter what language you use. It doesn't matter what automation tools you use. Cloud Native is about your build process, not your tooling. Now, with that said, there are many very common, particularly open source tools that people use to realize a cloud native way of working. Jenkins, GitLab, Terraform, Packer from HashiCorp, same company that makes Terraform, Kubernetes, Docker. You'll hear these terms and interact with these tools if you're doing any cloud native work, but they aren't the same thing as cloud native. They are simply a means to achieve an end. We'll talk about some tools and techniques for building cloud native applications on Alibaba Cloud later. So what is cloud native exactly? Again, it's a way of deploying and managing applications. So really it's about managing the application lifecycle from development through to deployment and then running, iterating, and eventually retiring your applications. And during that entire application lifecycle, the cloud native approach is geared toward getting the most value for your time and money out of a public cloud platform. It could be Alibaba Cloud, it could be another public cloud. The idea is building scalable applications in an automated way that's reliable with good built-in monitoring, good operational qualities. The application should be easy to maintain and update, and good auditability. You should know who changed what and when, and you should have full logs for what the application is doing once it's deployed and running in production. Those are important parts of building an application in a cloud-native way. So Alibaba Cloud's cloud-native portfolio is large. We won't have time to talk about all of this today, so I'm going to try and focus on just a few key tools. We're going to stay focused on our container service for Kubernetes and on our container registry. And we'll also talk a little bit about ECI, which is a serverless way to run Docker containers. It's often used alongside our Kubernetes service. So we'll focus on those core tools because container-based workflows have become such an important part of cloud native. I should point out also that Alibaba Cloud is not alone in this. We are a major beneficiary of these open source projects, and we also contribute back to them. We're a general member of the OCI, the Open Container Initiative. We're a member of CNCF. We're a platinum member, actually, of the Cloud Native Computing Foundation. Our Kubernetes service is a certified Kubernetes service, meaning the Kubernetes people certify that our Kubernetes deployment on Alibaba Cloud works in a standard way and is compatible with all of the parts of the open source Kubernetes ecosystem. We also participate in some other projects like the CNCF Technical Oversight Committee and the Moby project. So we're actively involved in giving back to the open source community. We're not doing everything on our own in-house in a proprietary way. We want to be a part of this shift to this open source cloud native way of working. So let's start by looking at Kubernetes in a little detail. There will be some background information in here for people who are new to it. If you're totally unfamiliar with Kubernetes, don't worry, I will give you a brief overview. If you're already an expert in Kubernetes, also don't worry, I'll be keeping the overview short, so it won't take up too much time. So Kubernetes, or as it's commonly known, K8s, is an open source container orchestration platform. Basically, it helps you automate the management of containers, especially, say, Docker containers. Docker is one of the most popular open source container engines available today. Often when people use Kubernetes, the container engine that they're using with it is Docker. So what does container orchestration mean? It means managing the way that containers are set up, monitored, shut down, scaled, and how they interact with each other. So configuring their networking and their logging. You need automated systems to help you do that because in most modern applications, you're going to have multiple containers running all at once. They're all going to be doing different jobs. You need a way to deal with them if they fail, maybe restart them, monitor them, do load balancing. You don't want to do that by hand. So Kubernetes helps you with that job. I'll probably pronounce this wrong, but Kubernetes actually comes from the Greek, I think, Kybernetes, which means helmsman or pilot. So Kubernetes is sort of steering the ship. So you can think of like a container ship, right? Full of containers, and you are the pilot of the ship, controlling where it goes and managing your cargo. That's what Kubernetes does, and that's how it got its name. So the actual underlying workload, your application itself, is actually published and run as a set of containers that would run on top of a container engine like Docker. If you don't know what a container is, the simplest way to understand it is it's like a self-contained package for running a piece of software. It contains that piece of software, its configuration, and any other tools that it depends on. And you can sort of load the container into a system like Docker, and Docker will automatically run it. And anywhere that Docker runs, that container should be able to run just fine. So it's a nice portable way to package up software. And again, Kubernetes has the wonderful job of automating the running and management of containers. Not just Docker containers, it supports other container engines as well, but Docker is one of the most popular tools available for running containers, especially in Linux. So Kubernetes is designed to run on a cluster. In production environments, Kubernetes is usually not going to be running on a single machine. There will be multiple physical servers or multiple virtual machines that make up the cluster. And there will be at least one master that coordinates the nodes, which you might think of as workers. The nodes, which you see in green on the diagram here, those are actually where your containers are running. So if you're using, say, Docker containers, your Docker daemon, the tool that runs the Docker containers, is going to be deployed on the nodes. And the master's job is essentially to monitor the nodes and make sure they're doing what they're supposed to do. So when you interact with your Kubernetes cluster through the Kubernetes command line tool, kubectl, or through a web UI if you're on Alibaba Cloud, when you communicate with that master, you'll be sending commands telling it what you want the state of your application to be. The master will take those commands, compare them to what's happening on the worker nodes right now, and will then make any changes that are necessary to get the cluster into the state that you asked for. And the way you do that is very unique. The way you actually tell the master what you want it to do is a little bit different from what you might expect if you come from a traditional IT background. So the master runs these components, the API server, the controller, and the scheduler, and they maintain sort of a database layer called etcd that keeps track of the state of your cluster. And when you submit something to the master node, what you actually submit is a YAML formatted text file that describes the end state that you want the cluster to be in. So unlike in traditional IT where you have some desired end state and you execute the commands required to get there, so you need to know what to do to get to that end state, unlike that, in Kubernetes, you tell the cluster, this is what I want the state of the cluster to be, you go figure it out. And then the master's job is to make that end state happen, to achieve it somehow. So this is really interesting. This is very different from what you might be used to. Essentially, you're declaring the end goal, and the master is figuring out how to get the cluster to reach that end goal for you. So the way you do this is by writing these object files, which again are just YAML formatted text documents, and they define resources that are going to run on the nodes, the worker nodes. So for instance, probably the most common type of resource in Kubernetes is a pod. A pod is a collection of one or more containers, say Docker containers, and some storage volumes for those containers to talk to, and networking support. So the pod can talk to the Kubernetes cluster network and communicate with other pods. And you'll write a text file that says, okay, I want my pod to look like this. It should have X amount of memory, and it should use this particular Docker container image when it boots up, and it should be able to mount this storage location. And you send that description to the master node. You send it this pod object file, and then the master node looks at that, finds a worker, finds a node in the Kubernetes cluster that has spare capacity, and then launches the pod. It will start the pod on one of the workers for you. You can then group pods into what is called a deployment. So imagine for a minute that you're running a new website. Maybe you've built some new e-commerce website for yourself, you're selling t-shirts or something, and you want the front end for that website to actually be spread across multiple pods. Perhaps you're getting a lot of web traffic, perhaps you just want extra redundancy in case one of the pods fails, but for whatever reason, you want to have that web service running across identical containers. So what you'll do is you'll write a deployment object file, which again is another text file that says, give me X number of pods, boot them from this container image, give them this much memory, etc. And then you pass that to the master, and the master makes it happen. It figures out where to put those pods, which node they should run on, how they should be networked, how they should be grouped. It will do all of that for you. And then, of course, you might then want to make your pods accessible from the internet, especially if you're running a web service. So at that point, you'll write another one of these object files, which is again just a text file, that says, please create a service for me. And I want the service to listen on this particular port. I want you to give it a public IP address. And whenever a request comes in on this particular port, please pass it to one of the pods in my deployment. And then Kubernetes will happily take that incoming traffic from your users, look at it, pass it to one of the pod will process it, and then a response will go back to the user. And almost all of this is automated. You simply write the object files, and the cluster figures out how to implement what's written in those object files. It's that simple. So I don't want to spend a lot of time talking about how to use Kubernetes. That's at least a few days worth of content. We don't have that much time today. So what I'd like to do instead is focus down a little bit on what we can provide, what sort of container services Alibaba actually provides, or I should say Alibaba Cloud. So on top of our container service for Kubernetes, or ACK, we also provide additional tools to help you implement additional services like sandboxed containers or hybrid or multi-cloud deployments. You can actually link your Alibaba Cloud Kubernetes cluster to a Kubernetes cluster that's in your own data center or on another public cloud. We provide tools for accelerating machine learning tasks. We provide Kubernetes cluster configurations that include GPU hardware in case you're doing machine learning training or inference. There's a lot of additional supporting products that sit around the core Kubernetes cluster that we provide to you. And there are generally two paths, two ways you can go when you're implementing Kubernetes on Alibaba Cloud. You can go with a managed or a dedicated cluster, or you can go with a serverless cluster. So you can see managed and dedicated are on the left. I like to call that traditional, the ones on the left side of the slide there. The traditional cluster essentially is running on ECS, so it runs on ECS virtual machines within your Alibaba Cloud account. That means you have to do more management work. You have to decide how many worker nodes there will be. You have to decide whether or not you want to manage your own cluster master node. We can manage it for you, or you can manage it yourself. You have to decide what hardware specification your ECS VMs are going to run on top of, what ECS type, how much memory they should have, how much CPU they should have, how they should be networked. That's all you. You get a lot more control that way, but it's also more work. Serverless, on the other hand, on the right-hand part of the slide, that actually runs on top of ECI, our Elastic Container Instance. This is just a serverless tool for directly launching Docker containers. So what you do with a serverless Kubernetes cluster is your pods actually just run directly on ECI. You don't have to manage a master node or any workers. The entire cluster, from your perspective, is managed by us. It's simply a platform that you utilize. You don't have to do any management work. And we enable that using this tool called ECI, which is just a serverless way to run Docker containers on Alibaba Cloud. This allows you to to run containers without having to provision any hardware yourself. And of course, under the hood, this is actually running on the same physical hardware that our ECS service runs on. It's just that you don't have to manage the deployment of any ECS instances yourself, which is great because that means that your cluster can scale up and down on demand pretty much immediately within a few seconds. So we actually implement our serverless Kubernetes service by taking one of our managed Kubernetes master nodes and tying it to ECI. So if you log into a serverless Kubernetes cluster on Alibaba Cloud and you ask it to give you information about the nodes in the cluster, it will return a single virtual node, and that virtual node is actually pointing at the ECI service. So what that means is that whenever you launch a new pod, that virtual node pushes the pod onto ECI and it just runs there automatically. Serverless is really great. This is the next level in cloud native, I feel, because you focus only on writing your own code, launching your own application. You're no longer focused on running infrastructure. That is now somebody else's job. You don't have infrastructure to deal with. You also get perfect scaling because with a serverless Kubernetes cluster, you're not actually managing the nodes in the cluster anymore. You can scale up to whatever level you need. Your cluster can get as big as it needs to get automatically. We are heavy users of Kubernetes within Alibaba Group. Alibaba Cloud supports most of the other Alibaba Group businesses like Tmall and Taobao and AliExpress and Lazada, these things. They're actually running on top of Alibaba Cloud, and almost all of them are containerized. And the reason is you get much better scalability this way. If you're using serverless Kubernetes plus ECI, scaling up and down is entirely automatic. So you can see here, if you're using a serverless Kubernetes cluster on Alibaba Cloud, that cluster actually consists of a single virtual node. So you can see in the lower right-hand corner there, if you were to go into kubectl and type get node or get no, which is short for get nodes, what will get returned to you is a single node. It just says virtual kubelet. That is actually a pointer to the ECI service, and any containers that you launch, any pods that you launch, will actually get launched onto ECI. This is really good for hosting applications that need to scale frequently, like websites or game services. It's also great for jobs that only run intermittently, like proof of concept work or CI/CD pipelines or things that you're testing, because when you're not running those jobs, your cluster can scale down to 0 pods, and then you're not charged anything at all. So it's great in terms of cost for bursty jobs as well. And it's pay as you go. All the bills for serverless Kubernetes are generated after you use the service. You don't have to pay up front. It's clusterless, namespaceless, nodeless. All that management work is gone. You just define those object files I talk about. You just define those object files that I talked about earlier, like a pod or a deployment or a service. You pass them to the cluster through the web console or through kubectl, and it figures out what to do. It's that easy. A great example of a use case for ASK, or Alibaba Serverless Kubernetes, is a CI/CD pipeline. This is a great way to use the serverless Kubernetes service because, again, it can scale up whenever you need to do a build or a deployment and then scale back down to nothing when you're not doing a build or a deployment, which saves you a lot of money. So you can see here, you could write your code, commit it up to a repository like your own GitHub repo or a GitLab deployment. You would then pass that via a webhook. You'd pass a notification from your GitLab or GitHub repo over to your Ask cluster, which could then spin up some containers running Jenkins or GitLab runners, do your build, do your unit tests, and then do your integration testing and deployment all automatically. In terms of customers that are actually using this in production, I would say one of our best success stories is Weibo, Sina Weibo. This is a major microblogging platform in mainland China. I'm not sure if all of you are familiar with this, but Sine is one of the biggest microblogs here. I'm not sure how to characterize it. It's short form blogs, so it's sort of like a cross between Twitter and Medium, I guess you could say. And they're actually using our Kubernetes service in production to do real-time computing for automated recommendations. So they're taking in billions of data points. So user clicks on their website, new articles going up, traffic to various articles on the site, billions of those samples. They've got a sparse model to try to recommend articles that has literally trillions of dimensions. And they need to be processing this data in near real time and then using it to train and improve a machine learning model that does automated recommendations. And then they need to offer those recommendations to users in real time. And they're doing that entire workflow end to end on Kubernetes, on top of a Kubernetes cluster. Okay, so let's look at another aspect of running a cloud native deployment. Let's say you're sold on Docker and Kubernetes, you're definitely building a containerized application. You now have another problem. Where do you store your container images? So where do you put your Docker container images? For that, we have another tool called Container Registry, which is what I want to talk about next. So Container Registry is a global Docker image repository system. It covers all of our 25 regions and 80 availability zones around the world. It helps improve replication speed between different regions. It's able to do large-scale distribution. It has a built-in peer-to-peer Docker image distribution tool that actually speeds up image push across larger Kubernetes clusters. It's a very efficient tool. One of the coolest features for me is that the Enterprise Edition has the ability to automatically take a Docker image that was built in one region, like Hangzhou, and push that out to multiple other regions simultaneously and automatically. And it does this over Alibaba Cloud's private internal network links, which means there's very low latency, even if you're going across the Chinese border. So if I build my image in Container Registry in Hangzhou, and then I want to push it out to Hong Kong, Singapore, and London, I can do that really, really quickly through the enterprise version of Container Registry. It gets done automatically. And Container Registry isn't just a storage tool, it's actually also a build tool. So I can link Container Registry to GitLab or GitHub, and whenever I submit a new Docker file there, I can send via webhook a notification to Container Registry, which will then pull the new Docker file and perform the container image build for me before pushing it out to those other regions. So it really helps me to automate. It also has, again, this feature for large-scale image push, which makes it possible to take a Docker image and push it out to thousands or even tens of thousands of Kubernetes worker nodes all at once. This tends to improve efficiency by something like a factor of 4. It really, really speeds up image push. And it even does Docker image snapshotting, which can allow you to get a refreshed copy of an image without pulling the entire thing. It does basically incremental snapshots for Docker images, as you can see in the workflow on the bottom of the slide here. It also has the ability to do some built-in security scanning, which is very nice. The Enterprise Edition of Container Registry has a vulnerability reporting tool that can actually be used to scan Docker images that you've built, and then even better, it can sign them. So it can use our KMS, our key management service, to sign your Docker images. You can then actually set up your Kubernetes cluster so that it only is allowed to run images that have been signed by Container Registry. That will keep users from deploying images you haven't put through your security scanning process, which means if you have a developer that tries to pull something from Docker Hub without your permission or tries to build their own image outside of this security pipeline that you've built, then the cluster will refuse to run that, which is a really nice security feature. And this is really something that all companies need to be adapting to. Containers are the new normal. These are actually old figures. These are from a few years ago, back in 2018. At the time, 84% of the companies surveyed by the Cloud Native Computing Foundation were running containers in production. 78% of those were using Kubernetes. And by that point, companies were starting to adopt even more advanced things like serverless and service meshes. That adoption rate obviously has gone up. It's been a few years since 2018. If you go check out the CNCF website, they have some additional newer statistics that are worth looking at. And then finally, I wanted to talk about DevOps. So we've talked about some of the tools that are used to work in a cloud native way. What about some of the workflows? What are the processes that people employ to do all this automation that I talked about? How do you make all this work seamlessly? One of the approaches is what's called DevOps. It focuses on bringing developers and operations people closer together and aligning their work a little better. And there are multiple definitions for what exactly DevOps is. The one I like is the one on the right-hand side of the slide here. DevOps is a set of software development practices that combine software development and information ops to shorten the system's development lifecycle while delivering features, fixes, and updates frequently. And I bolded that sentence because that's really what it's about. It's about taking the time from writing a new line of code or modifying an application to getting it into production and reducing that time. That's what it's about. Your deployment cycle needs to be shorter. Ideally, you should be able to go from new code to production environment as fast as possible. That's the goal with DevOps. And of course, that means doing lots of automation. You want to take humans out of the loop whenever possible because people have to go to lunch, they have to go to sleep, they have to get off work at the end of the day. People sometimes forget a step or make a mistake if they're following a complicated deployment process. Computers don't. So ideally, you want to automate as much as possible. And there are really 4 key areas in DevOps that you focus on automating. There's storing code, building code, testing code, and developing code. And you can see here on the slide, I've pointed out some tools that are used for that. There are multiple tools you could use. These are just some of the more popular ones. So to store and build, it would be maybe GitLab or GitHub, plus another tool like Docker to actually run the build process. For testing, there are a number of different toolkits you could use. It really depends on what programming language you're familiar with, which tools you like. SonarQube is popular with Java developers. And then deployment is usually going to be done using additional infrastructure automation tools like Terraform or Packer, which actually can automate the deployment of a Kubernetes cluster on Alibaba Cloud. You could even have your Kubernetes cluster be spun up on demand, fresh, every time you change your code, if you wanted to. You don't have to do it that way. So when you're focusing on adopting this type of a DevOps workflow, you might end up with something like what you see on this slide here. So you'll start out by writing Docker files for each of your applications or application components. The Docker file will describe how your software should get packed into a Docker container and how it should start when that Docker container is running. You then take that Docker file and your application source code and you'll store it in a source code repository. You can then set up webhooks so that when your code changes or when your Docker file changes, that will trigger a container registry to build new Docker files, and it will trigger a continuous integration and continuous deployment tool like Tekton or Jenkins to rebuild and redeploy your app, and maybe even push it out to more than one Kubernetes cluster if you've got production, staging, and development environments, which is always a good idea. You should have separate environments, at least for development and production, maybe for staging also. So a typical pipeline would look like the one here, and you might choose to pair that with cross-border image transfer. So especially if you're trying to do localization for compliance reasons or just to speed things up, you're going to want to have your application deployed in multiple geographic locations. A tool like ACR, Alibaba Container Registry, can take your Docker file and your code, build it, pack it together, and then ship it from one of your Alibaba Cloud regions to another so that Kubernetes clusters, say in China and somewhere in the EU, maybe Germany, can pull down a local copy of that image, which is much more efficient, much faster. And then just to wrap things up here, let's have a little retrospective here. So I am from the Alibaba Cloud Academy. That's my core work. I'm an educator here, and we offer a wide variety of different online and offline training courses that go into a lot more detail on all of these subjects. If you're at all interested in any of this, feel free to check us out at edu.alibabacloud.com. We've got online labs you can try. We've got video-based training available on our website on demand. We also occasionally run training on Zoom or through DingTalk broadcasts. DingTalk is Alibaba's chat tool. And we also offer certifications in computing, security, big data, and a few other things as well. If you're interested in any of those, don't hesitate to check out edu.alibabacloud.com. support.alibabacloud.com. And finally, I have a free certification to offer you. We have a little 15-question quiz that's related to Kubernetes. If you paid close attention to the intro on Kubernetes, or if you're already an expert, this quiz should be pretty easy for you. Just scan the QR code or follow the link at the bottom of the slide here to check that out. If you answer enough of the questions correctly, then you'll receive a nice little certificate that you can post on LinkedIn or Twitter or wherever. And with that, I'd like to thank you for joining me, and I hope to see you in a future session.